So we talk about physical and chemical properties, and they are closely related to physical and chemical changes. So in a physical change, the matter may change its appearance, but its composition doesn't change. So when ice is melting, it looks different, but it's still water. The particles are the same, the composition is the same, but its form has changed. If you take a piece of wood and you cut it in half, you've changed its appearance. It's not as long as it was. Is it still wood? Yeah, it's just in two pieces instead of one. That's a physical change. In a chemical change, the matter does change its composition. So copper will turn green upon continued exposure to air because it reacts with gases that are present in the air and it forms new compounds. So we see that copper goes from shiny and bronze colored to that verdigris color, that sort of a greenish color, and it's not shiny anymore, it's dull. And that's a chemical change because the composition has changed. So state changes are always physical changes. The atoms are not changing, the molecules are not changing, they're changing in appearance, but the physical change just results in a different form of the same substance. So you boil water, it's still water. Chemical changes involve the atoms changing their fundamental associations. They may have been atoms before, and now they're becoming parts of molecules. The individual atoms don't get destroyed, but their associations do. So chemical change results in new substances. A chemical change is a description of a chemical reaction. So when matter undergoes a chemical change, we say it undergoes a chemical reaction. So we can write equations for this. It's a shorthand description of a chemical change. We put the reactants here, and then we have an arrow that indicates direction, and the products over here. Just like we have conventions for reading, we start at the left and we go to the right. We have conventions for writing equations. The reactants start on the left, because when we're reading, this is where you start. The arrow points to what you're making, and this is the products. So the reactants react to produce the products. There are a lot of terms and words that we use in science that could seem confusing on the surface, but we're actually trying to make things easy. The products are what is produced. The reactants are what reacts. And so this arrow is representing a chemical change. So here we have an illustration of a lighter. It's got liquid butane in it. So these are little butane molecules. In the liquid, they are very close together, but they're shifting around, moving around. It's a liquid. When we flick this, but we don't actually get a spark and get it to light, and we just hold it open, the liquid butane will evaporate and become gaseous butane, and it will escape from the lighter. If you just hold it like that long enough, all your butane's gone, the lighter's not going to work anymore. Did anything happen to these individual molecules when we did that? No, they're the same. These pictures are nice because we can see them. It'd be great if we could just zoom in and see molecules. Unfortunately, it's just not possible. This is a physical change. Did something change? Yeah. We had all of this liquid in here, and after we do this for a while, a bunch of it's gone, and all this gaseous butane is out here. There was a change, but the individual particles are still the same. A physical change does that. A chemical change destroys or changes the substance. So if we flick the Bic now and actually get it to light, the liquid butane, as it comes out here, is reacting with oxygen from the air, and it's producing water and carbon dioxide molecules. The butane molecules are no longer present. We have different molecules. It's like we took these apart and combined them in a different way. That's a chemical reaction, a chemical change. Any questions? Classify each change as chemical or physical. So a copper metal forming a blue solution when it's dropped into colorless nitric acid. Chemical. The clue there is that we see the color changing. So we know that copper isn't blue, but it's making a blue solution. Copper metal is a solid, and now it's forming a solution. So there are several clues there that this is a chemical change. A train flattening a penny placed on a railroad track. That's physical. It's still made out of copper. It's just in a different shape now. It's smashed. If you want to smash pennies, just use the machine that smashes them. Don't put pennies on the railroad tracks. I know lots of people did that, but it's not safe. Ice melting into liquid water. Physical or chemical? Physical. That's a state change. Anytime you see melting, boiling, freezing, anything like that, state change, physical. A match igniting a firework. Chemical. That's going to give us an explosion, right? And we're going to see light and probably hear sound. And the firework is destroyed after we do that. We can't do that over and over again. Any questions? Mixtures can be separated through physical changes. So one method of separating a mixture is called distillation. This separates liquids based on their boiling points. So if you have a mixture of ethanol and water, ethanol is alcohol, it has a lower boiling point than water does. We can separate the two substances by boiling the mixture. The alcohol will boil first and will go into the gas state and leave the water behind. If we want to collect that alcohol, we need to contain it and not just let it go off into the atmosphere. This is called a condenser. It's a double-walled tube, and we run cold water through the outer tube to cool it, and that causes it to condense, and then it runs down in here. That's the basic idea for distilling alcohol. So making vodka or whiskey or moonshine. During Prohibition, people set these up in the woods, and unfortunately, they didn't always know what they were doing, and so they often killed themselves because it exploded on them. Besides, it was illegal, but that's distillation. You can separate two liquids based on differences in their physical properties. When you're done with the separation, there's a physical change that has occurred because these two things aren't mixed anymore. But the water molecules are still water, and the ethanol molecules are still ethanol. You haven't changed what the substances are. We can also separate things by filtration. And you've probably done this in your kitchen if you've ever made spaghetti, right? You boil water, you put the spaghetti in, it's done. You have to get the spaghetti out of the water somehow. And the best way is to use a colander, a big bowl with holes in it. That's making use of the physical differences in state. The spaghetti's a solid, the water's a liquid. The water will go through the small holes, the spaghetti won't. In chemistry, we use stuff that's maybe a little fancier. So here's a glass funnel, and we put a piece of paper in here. Here we have a mixture of a solid and a liquid, and when we pour it through here, this is going to be slower than the filtration of cooked spaghetti, but the liquid can go through the paper, the solid cannot, and so we separate the two. Those solid particles are not changed by this process, they've just been separated. So it's a physical change to separate a mixture. Any questions?